Welcome to BEC Tech Academy. My name is Evgeny Nurminsky. I am DevOps Competence Manager in BEC Poland.
And together with Evgeny is Kamil Kościesza. I'm the Mainframe Competency Manager in BEC Poland as well.
So today we would like to start a series of external events which we organize for the industry and to unite different great minds across the industry to showcase that different technologies can be leveraged in a financial sector, industry, and beyond. Today, it's a first session. Today we unite two topics of QA and DevOps, and specifically we are interested in how Mainframe is fitting within this picture. So to do that, we invited Rosalind Radcliffe, who is a distinguished engineer at IBM, who has a lot of experience on mainframe area and making sure it's up to date with the industry standards and trends. And on the second half, we'll be talking with Kuba Roshinsky about QA automation and how to approach automation when not all the project is kind of known, not all the aspects of the project is known beforehand, and what to consider before actually attempt the automation process. So today, right now, we're starting with Rosalind. Stage is yours. Welcome.
A little bit about myself. I have been responsible for making ZOS DevOpsable. So that has been my role. Most recently, however, I've moved into a new role in IBM, and I'm working on DevOps or DevSecOps for IBM internal as well. So I still work with clients in DevOps transformations, and I get to work in our internal DevOps transformation as well. So I want to start a little bit with, and as people who know the mainframe, we all know that IBM Z is the back-end system that is used for running transaction processing systems, banking, insurance, the world, or as we say, it runs the world. It's the back end of the world. But it's important to recognize that Z sits alongside of the rest of the applications, and it's the feed for many applications. And so we need to think about Z in context of the hybrid cloud. And we need to think about this application or providing business value that crosses the spectrum of systems, whether or not they be running in a public cloud, in a private cloud, on-prem, in ZOS, and the line needs to blur about where you're running the capability. We need to think about designing the capability and building capabilities such that they run where they belong. They run on the platform or the environment that makes the most sense based on the qualities of service required for that piece of workload. When we look at Z itself, the system itself, it has been transitioning and is the most modern system out there. It has the capability to run what language you want to use. It, however, has additional capability in providing that truly reliable hardware underneath the system. And so you have the advantage of the hardware providing a set of capabilities. On top of that, you can write the application however you wish to. Now, we have a lot of traditional applications that have been around for a long time, though, running on IBM Z. And as I like to say, the best thing about IBM Z, in addition to its qualities of service, is that anything you've ever written and compiled for IBM Z will keep running on IBM Z. And the worst thing about IBM Z is that everything you've ever written continues to run on IBM Z. So we have to take advantage of the fact that things keep running, but we also need to think about what the modernization and the improvements that we can do to those applications. So the hardware itself has evolved and has modernized and fits in standard data centers. If we look at the latest announcements around chips, we look at Telum processor, and we think about AI built into the system as we move forward, advanced capabilities, we can use the system for more and more as it fits in the environment. But if this really is our world, if the hybrid cloud really means I want to write things in one way, I want to work in a particular way, I should be able to use Z in a consistent way as everything else. And so there are a set of patterns that have been developed to help modernize the applications that have been written running on the platform. And so, yes, the machine has evolved. It continues to evolve, continues to have new versions come out. When we think about the hardware itself, when we take the layer up and look at the applications that we run in that system, we need to look at what are those patterns for modernization. And there are a set of enablers that come with this. And this DevOps practice, the practice of development and operations and the ways of working and security and business and everyone coming together to deliver business value, this transformation is important to include Z, and it's a foundation. The other piece of this foundation is not only that DevOps transformation from a culture and practice standpoint, but also from an automation and tools standpoint. So making sure I have this one way of working across the organization, whether or not I'm doing COBOL PL1, assembler, or Java or .NET or Node.js, it doesn't matter what I'm writing, what my application is going to run in. I want that same set of processes, practices, and underlying tools. And once I have that, then it's easier to do the servicification, as I say, the creating of services out of those existing applications, or exposing the data in new ways, building data fabric that includes Z side, or moving to more event-driven architectures, including the backend systems. So there are lots of opportunities in this process to build your applications, update your applications so that they have this consistent, I can work the same way across the processes, I run the application where it belongs. And as we think about these patterns for improvement, we start out with the first space, the DevOps space. And one of the things I've been doing for the last 13 plus years, talking about this, Z isn't really that different. Yes, it has a set of qualities of service, but when I think about the culture, when I think about the practices, the ways of working, bringing that consistency, ensuring that if I'm doing a front-end application or a back-end application, the way I work is the same, then I can bring better value to the organization because I'm not doing something different just because it's running on a different platform. So it shouldn't matter whether or not I'm building toward Z or I'm building in the cloud or I'm building an API. It doesn't matter. That same way of working, that consistent set of processes is the critical focus when we're doing this work. And we all, in support of this, need a pipeline. And this is a picture about a pipeline. There are numbers of different ways to think about this. But if we're gonna do DevOps, if we're going to focus on bringing automation, visibility, and transparency to the organization, we need that automation piece. We need to be able to automate absolutely everything that is a repeatable task. All of those things that developers, testers, everyone, operations staff don't want to do because it's just a manual, repeatable task that you do over and over again. It is an opportunity for error. It is an opportunity for problems. And by automating those out of the system, people can focus their efforts on the business value delivery, making sure they're writing the application business logic, making sure they're writing the appropriate tests, making sure they're focused in this value delivery rather than the things that can be automated. And so we want to make sure we end up with this pipeline that allows this fast feedback, that allows you to go from code to build, provision, deploy, test, release into production, making sure I'm monitoring. Now, there is no perfect picture. There is no way to draw this picture correctly, totally, because I need to monitor all along. I need to be analyzing. I need to be understanding. So there are, we can't make it a perfect picture, but at least it's closer to show those feedback loops as early as possible, to get that information back so that you understand if there's a problem early, getting that early testing, getting that early feedback. Now, one of the things as we look at this pipeline, you see provision, deploy, and test. One thing that has traditionally been different about ZOS environments is we have generally given developers a dev environment or a hierarchy of environments. I start in dev, I go to test, I go to QA, I go to production, or some level of hierarchy. In the distributed world, we spin up environments. I can spin up a container. I can do what I need to do. Well, that same thing is true for ZOS. And there's no reason I can't provision, deploy, and run my test in the same way for ZOS that I do in any other environment. And so getting this consistency, bringing this commonality to the environment makes it much easier to improve, to give people the flexibility for innovation in the applications. If I don't have to worry about stomping on someone else, if I can have that isolated environment, if I can run those automated unit tasks, because I have an environment capable of doing it, makes it a lot easier to get that fast feedback and make sure I'm delivering business value as appropriately as possible. One of the things when we talk about DevOps and we talk about these transformations, we generally talk about the DORA metrics. We talk about what metrics am I going to use to help make sure I'm improving my processes. And it is important to recognize that metrics drive behavior. And so whatever we're going to measure, people are going to work to that metric. And so if our metric is delivery to production, we're going to get more deliveries to production. But we have to be careful about that metric. Yes, we want to be able to deliver to production as soon as business value is available. Absolutely. The pipeline needs to be as quick as possible and as efficient as possible. But we also need to recognize that delivery of business value may mean I don't need to deliver multiple times a day. In many systems, if I have to deliver multiple times a day, then I just have a buggy system. It's not that I'm delivering business value. So we do need to think about our metrics to ensure that we're measuring the behaviors we want to cause. One of the really valuable metrics really is idea to delivery into production. How long does it take from the initial idea to having it running for end users? That measure includes everything that's part of this, the business side of the idea, all of the piece parts. And that gives us an understanding of how effective and efficient we are in our delivery. Have we automated out all those processes that we possibly can so that we can focus on that delivery of business value? When we think about this in the mainframe space, I've kind of blown it up into more specific to really drive home that in the ZOS space, in addition, I can really do this modern development process. I can really give developers this option of having their isolated set of capability and allow them to do their work independently so they can get that feedback, so they can understand what they're doing, so they can understand if the change they made will have impact on other systems. And then it can flow into the environment, allow those changes to be merged together. This process looks just like any other process that a developer might do, and that's the intention. Making the process, whether or not you're Z development or your Java or your whatever you are, having that exact same process and allowing the same flow. You'll notice in my picture, I have things like artifact repository. One of the other thing that is really important about this picture and this process is that we need to make sure we're including security as part of our discussion. And there are different discussions about security. And when we think about open source, we think about open source vulnerabilities and open source security, scanning code to ensure that we don't have any known vulnerabilities. When we're looking at our own proprietary code, then we're not necessarily looking for open source vulnerabilities, but we still want to focus on making sure we're building code where we're thinking about security in the first place. We're testing for security as much as we can or as appropriately, getting that fast feedback, having things like code rules in the system so that I can make sure I'm meeting the standards for how I expect code to be written. Getting that quick understanding, focusing on, am I building a secure system? Am I thinking about security as I begin through this process? And as I build my artifacts, put them in an artifact repository so they are locked. So I can build a closed pipeline so that I can ensure something else isn't brought into the system. So I can ensure that security around the system of this is the change that I meant to make and something didn't get into that environment. The other thing you'll see on the picture is a pull request or a merge request or whatever it is, making sure that you have someone else looking at the code. Now, I talk about automation and I talk about automating everywhere, but there are certain places where it is very helpful to actually have that human involvement. And so that second set of eyes on the code to help provide guidance, to help provide information, to help make sure you're not doing something that you shouldn't be doing. In the US, at least, we have something we refer to the half-cent law, or the regulations around making sure in the financial industry that you don't put in code that lets you take that half cent, that rounding error, and take that money. Well, that's just an example. There are plenty of examples where we need to think about having a second set of eyes on the code to make sure something isn't put into the system that we don't want put into the system, to make sure it's reviewed. There are lots of reasons for this review. Security thought processes, coding practices thought processes, as well as just sharing information. By having a pull request process, different people learn more and more parts of the code. They get to learn more about the system. Some people use pair programming approaches. However, we're getting 4 eyes on the code to make sure it's being built and delivered appropriately. All of these practices apply no matter what language system I'm building for. Bringing it into the ZOS world, making sure we're following these same practices helps ensure we're delivering code in a secure fashion. The other piece that's really important is testing and automated testing. And I know you have a session talking about that next. But I want to bring in a couple of points at this early stage. When we think about mainframe and testing, in many ways, we've been thinking about, I'm going to do that end-to-end testing in that end-to-end environment, and I'm going to test that way, or I'm going to do functional testing. We really have to shift this. We really have to move this. And the idea of having the ability to have these extra environments helps this process. So I can have this concept of provision, deploy, run my system, making sure that I get all the right testing done at the right stages, and test data management. The biggest problem with automated testing is test data. And when we think about mainframe systems in particular, we have a lot of data. We have a lot of data in the environment. And sometimes, and for some tests, a lot of data really matters. But for most tests, the early unit testing, making sure I have fabricated data rather than data from a production environment that may hopefully has been masked and obfuscated, but actually using fabricated data and making sure I'm doing all the error conditions, all the boundary conditions, all of those problems early on, so I can address all of those kinds of issues early in the process. Shifting that from a developer perspective to make sure that I've got my unit tests done and they are complete and they're part of the pipeline. Now, Z applications are many times very large. So as part of this process, we also want to make it very easy for those unit tests to run on the code that has changed. Different concept than we might do in the distributed space with bringing a jar or a war together or an application together. We really have this, I change a single load module, let me test that single load module. Let me make sure that does what I need it to do with all of the variability of data. And then move on into how does this load module work with other pieces in the system, making sure I'm doing that application integration test and stubbing out as much as possible so I can get that feedback even in the build by stubbing out the entire environment. And then moving on into these spin up, spin down kind of environments. And this spin up, spin down kind of environment is really critical. But how do you do this? How do I have this pipeline? How do I do this automation? Well, you do it like you do it everywhere else. You make sure that whatever your standard is for pipeline, you use it for Z as well. Whatever the way you do systems today, how do you do automation? Do you use Python? Do you use Ansible? What is it that you use for your automation? And that same thing can be done for ZOS. So that if I do this in a consistent way, one, I can use more skills. I can use the skills that I have in the environment. And two, I can do this in a consistent way so that when I'm building my application that is cross-platform, possibly cross multiple platforms, multiple clouds, I can do that and manage it in a consistent way. I can do the automation around it in a consistent way. I monitor it in a consistent way. So it's the automation and the pipeline and the capability. And only when there's something that's uniquely different should that be considered for Z. So I need a build tool that knows how to build COBOL, yes, but the pipeline tool can be the same, whether or not, your choice is Azure DevOps, GitLab, Jenkins, whatever it is. Making sure you're thinking about it from that perspective. What do I already have in the organization? Because if I use those standard processes and practices, it's easier to transform. There's another really important aspect about ZOS that I want to bring up in this transformation. And we're not building today containers that run in ZOS, though there is announced work about containers running, ZOS containers running in ZOS. Today we do have ZCX with Linux containers running inside ZOS, so you can have your application co-located and co-managed. But when we look at traditional ZOS applications, we look at the application itself and the application changes and the infrastructure related to that application. Since I'm deploying into an environment, even if it's a spin up, spin down environment, I'm deploying into an environment. It's important to have this idea of what really is provisioning a system and what is application deploy. Because application deploy needs to be completely automated as part of the pipeline. So whether or not I'm making an application change that's a load module or deploying JCL or a database schema change or a new transaction in Kix or IMS, all of that should be part of the developer pipeline and be part of that change. So in my SCM, I should manage the application and the application configuration so that I can make the change. And then the underlying infrastructure is then managed by the operations, the team that manages that underlying infrastructure. Now, there are two reasons that this line can be really important. One, by automating this entire application change, then there is no need to ask, go do this change in this environment. There are no manual changes with an application change, which means it makes it much easier to deploy more frequently. It makes it easier to ensure the change always happens reliably, and we're not introducing a problem via this. It also gives us this line so that we can have separation between the infrastructure and the applications. Many organizations have their infrastructure and systems outsourced. And so if you're working with an either internal team that's separate or an outsourced team, by having this line, you can work with the organization to have this automation at the application layer. Now, this provision bottom part should also be completely automated, and spinning up Kix regions, updating DB2, all of that should also be automated using the same kind of capability. But there is a line there. I should be able to deploy in with my application pipeline and then the automation below that. This line becomes very important when I'm looking at spin up, spin down systems as well. So if I'm going to spin up an environment, I need to make sure that I have this base layer well defined and allow to make application changes to that environment. So this split, this understanding of the various parts of the application are very critical as part of this transformation. In the distributed world, we've gone to containers, but in containers, we have the exact same thing. We have a set of layers that are being built to define that container. What portion of operating system, what packages do I need? And that container, that base container image is generally just as well managed and defined to say, this is what I'm going to use. And then you bring the application into it. And so this concept applies no matter what I'm doing. But in ZOS, we want to think about it very specifically to ensure we're addressing this line so that we can have application teams really getting that flexibility in their application deploy. The other reason the line is where it is, if we think about a ZOS environment, we have SMPE installable software. That all sits in the infrastructure side, all that's down there. And the top part is focused on that application change, that the changes that I'm going to need to make. Now, in some organizations, this does take collaboration across teams to make sure that the automation is built so everybody's comfortable with this kind of change. The other thing that's important to address as part of this conversation is the separation of duties comments, or the I have to have somebody else do the deployment when it comes to production. We've worked with many different clients on this process, and it is perfectly reasonable, and you can satisfy separation of duties requirements in the process by having the pipeline handle the deployment. It's not a developer who's actually doing the deploy. It's the pipeline that's doing the deployment. And it's done the deployment into test environments, and it's going to do the deployment into production. So you have this standardization. You reduce risk by using this automation. Make this much simpler from a process standpoint. And the separation of duties and the requirements around approval can be tied into the pipeline. And so the pipeline's not going to deploy into production until the right approvals and everything else is in place. I hope that with this transition to DevOps over time, people get to the point of approving most changes at the beginning, actually. So if the pipeline passes all of the quality gates that are added into the pipeline, there shouldn't be a late stage approval that says, yes, it's okay. It should be based on those automated quality gates and passing the tests so that it then goes. But that does take time, and organizations do take time to get to that point of the approvals at the beginning, assuming it passes all the automation. Now, there are times when there's a much larger change or a more impactful change that there's something later in the cycle. But the more we can get changes to be small changes that are flowing through the process that can just flow as appropriate. The other reason there may be a stop is you may choose that you only want to deploy into production in particular time windows or particular time frames because of peak utilization or because of the batch cycle, and I want to do it after the batch cycle or before the batch cycle. And so the pipeline should be able to handle that scheduling of, I really want this to happen after the batch window or before the batch window or some off time. So making sure that you have that set up so that when you go to production, it's one way of deploying all the way through is one of the key critical transformations in this process. One of the things that I've talked about is spin up, spin down environments. And this transformation to new ways of working. When we think about ZOS, I've been able to do this forever. I could have used ZVM to spin up a dev test environment. And in fact, in many places that I've worked in IBM, we have. In many clients I work with, they use ZVM to spin up new ZOS LPARs for test environments. In some cases, there are other environments that spin up, spin down within an existing LPAR, because an LPAR is a very large shared space, and I can spin up environments within an LPAR as well. So there are choices that are available. We made available a long time ago the ability to spin up using ZDMT on Intel hardware so that you could spin up in your environment, in your cloud environment, the ability to have this nice, and I've got to be careful, but I'm going to use this word, the nice toy ZOS. It's really true ZOS. But the thing that's so nice about it is you can give it to individuals. So individuals can have their own environment. And so it's always been a fun play space. It's used to train system programmers. It's used for all different reasons, But this ability to spin up, spin down on Intel hardware has been available. And it allowed you to do that early dev test in a way that allowed that isolated environment. Now, most recently, there's been an announcement to say we're going to have this equivalent-like function, except in IBM Cloud running on Z hardware. So by running on Intel hardware, it is true ZOS, but it doesn't perform the same. By running on Z hardware, it's still a spin up, spin down environment. There's still data layer virtualization, but it gives you this ability to easily, using a cloud BSI, spin up a ZOS environment. So you can spin it up as part of the pipeline. Clients are using this idea of spin up, spin down ZOS environments as part of their pipeline for that early development phase, for those personal pipelines, for that early development and test. And with being able to spin it up in IBM Cloud, you can go a little farther in the testing because it's running on Z hardware. Obviously, you still deploy it into existing LPARs to do that later stage end-to-end application testing, performance testing, scalability testing, but now you can get more options for doing early testing. By having a spin up, spin down environment, you can also deal with test data in a different way. You can put the test data into the system as you spin up the system so that you get that known data set to make it easier to do development. Now, we do have teams using this as a personal development environment. So individuals get a system to themselves and they can do their work. In some cases, it's a system for a team. So a sprint team gets one. We have one client years ago started down this process, and they provide one every sprint to the development team. They get a new image at the beginning of every sprint in the organization. Now, the interesting thing is these things go away. So they spin up, they do their work, they go away at the end. The first time they went away, people were a little more surprised by this concept of going away because your Z just stays there forever. And so it's a cultural change. It's driving this change to help people understand that it really is like building other systems. I can have a spin up, spin down, a throwaway system that I'm doing my early development and test on. Gives me more flexibility, gives me more options to play. One of the things, though, that I want to make sure I cover is the value and why you would want to do this. If we look at organizations and what they've benefited from, it helps show why I would want to do it. And there's organizational benefit. You know, I get to deploy more often, I get more business value, but there's also user benefit and team benefit. What does it take to change? What does it take to take advantage of this? And we look at the teams that have been adopting, the teams that have been transformation. They're giving the developers greater autonomy. They're giving the developers greater flexibility. And maybe it doesn't sound like that. I said, we're going to have a standardized pipeline. We're going to have a standardized way of working. But I do get more flexibility because I get more ability to experiment. I get more options on how I can do my work. I get more capability to do my individual work in isolation without affecting others. In one of the cases, RBC actually, they talked about the fact they went to one pipeline. So one way of working across the organization. And so whether or not I happened to work on the front end piece or the back end piece, it was the same process, the same tools within reason, same pipeline, same capability. And so I had this consistency of work. People could move between the different parts of the application more effectively. And it broke down additional silos within the organization. DevOps, the DevOps culture, the DevOps practices, it's all about getting people working together, providing that visibility, transparency, and automation. I need to break down those silos in order to do that. I need to break down the separation. And by making ZOS development, so applications for ZOS, the same as the rest of the organization, I can break down one of those barriers, one of those separations that cause people to say, that's different. That I don't want to do that because it's different. You can see the value, you can see the consistency across the board. The goal in these transformations was to really show the value that the ZOS environment was bringing. The fact that using ZOS, I've got this highly reliable backend system working seamlessly with this front-end system to support their digital transformation and really bring that value into the organization. All of these examples are clients who have moved and adopted many of the DevOps pipeline capability across the board. Looking at the examples here, making sure that they have this consistent pipeline in all cases. So no matter what they're doing, they have this same way of working. And there's another story, not on this chart, that has been told, so I want to bring it out. It was told by Allstate about how they've done their transformation. And the thing that was interesting about their choice is, yes, the mainframe team did their DevOps transformation after the distributed side. Distributed side had their pipeline in place and the mainframe team came into it. But the way they came into it was pipeline as code. So they were coming into the system doing pipeline as code, just like we want to do infrastructure as code. So in a sense, they called it day two DevOps. Well, when the new security requirements came down and everyone had to change their environment, the Z team actually was faster than the distributed team because they had this pipeline done as pipeline as code. They can make the change even faster, which is an interesting twist on this discussion. But if we think about it, we really are bringing this transformation. We're giving everybody this flexibility. We're giving everybody the choices to do this change. Now, the DevOps community is prolific in writing. There are lots of conferences, lots of events, lots of books that get written about DevOps and transformation. And I should update this picture because there's at least one other book that I want to add. The Unicorn Project and the Phoenix Project are just great fun reads. They're absolutely fun to read. Accelerate and talking all about the DORA metrics, very important to understand metrics and measurements and how you measure. Project to product, making sure we're doing the transformation so we really own that product. We take responsibility for that product end to end. The team topologies book was fun in reminding me how your applications represent your teams. And Gary always has good books, and Engineering Digital Transformation, his latest, well, probably not his latest, but one of his books on discussing how it applies to the enterprise. And shameless plug for my latest book, Enterprise Bug Busting, where I tell lots of stories about DevOps transformations and how you can bring it into Z. Hopefully that was helpful. And now I want to open it up for questions.
All right. Great, thank you very much. That's quite insightful, and we have a couple of questions which Kamil wrote, I guess, from the...
Yeah, so I have some questions from myself, but we had one question on LinkedIn, so I will start with that one. The question is from Adam Martin Britt, so probably you have had a chance to meet or talk with him. I heard you say that ZOS should only be different where it makes sense to be different, and I understand this is to mean that mainframe development should be more like the distributed world. But are there any parts of the development life cycles that distributed platform should adopt or learn from the mainframe?
So it really does depend on the answer, because different organizations have done things differently. There are a few things I actually like about ZOS development in the sense of standardization. So one of the things that has been true about Z has been there has been more standardization about the way I do things. And the standard pipeline really does help organizations. Now, you still need to give flexibility to development teams, and you need to give them options, but you don't need to give them options for everything. The standardization can help the organization implement security, put in the right controls, and provide support to teams so they don't have to do anything. And that's one place where I think in the Z space, we were ahead in some ways. The other thing is, and we're getting there in the distributed side, the control of the system, the control that I write my code in my environment and then automation handles it. And some companies have done that for quite a while. And so those are some of the good practices that we have in Z. There's actually another one that some people may debate, but when we think about the applications that we built in Z, we literally can change one load module to add new function, and we don't have to change the entire application. We don't deploy the whole thing every time. We do an incremental deploy. That ability to make changes at that low level, one might relate it to microservices in the distributed world, though they aren't microservices, and I'm not going to say that. But if we think about it, the ability to update only the part I need to change has actually been a real value. And it's a value and a curse, but it's a value that has really helped keep systems running. So that's something that in some cases would be nice if more of the distributed side could handle some of that kind of update and patch live on a system without having to make as many changes.
Okay, so I have another one, but this is one from me. What are the quick wins that you can see for the modernization of old mainframe installations? So in our scenario, we have the installation that's running for 40 years. We are using the Z15, but when it comes to modern pipeline, we are still well behind. So what are the things that you could recommend us to do, let's say, that's low effort by some visible effects?
So there are a lot of people, there are still a lot of companies that are, as I would put it, behind, in the modern DevOps transformation for Z. There are still organizations that I walk into that have practices that remind me of the 1980s when I started development on Z and ISPF. But you would be surprised, it's a lot easier to move into a modern pipeline than you think. Now, to move everybody, that takes a set of work. But to actually move, you know where your, well, okay, let's hope you know where your code is. It's in an existing legacy library manager. Getting the code out of there and into a modern SCM such as Git is not actually hard. There's tools posted to help you do that. There's tools as part of DBB, but there are ways to do this to get the source code over. Build practices, they're highly standardized. So pulling that out, and it's not as hard as you think. Now, is it entirely easy? No. Yes, you have to figure out what you're doing, but we've had small companies move in 3 months. We've had very large companies that from idea to having 9 applications in production, it took them 9 months. We have large companies, huge companies who've done it in 2.5 years, but it didn't take 2.5 years. It took 7 months to move the first application team, and then they kept moving more teams. The value to getting into a modern pipeline is really high, and it's less work than you think. I mean, it's more work than nothing it is work, but it takes a team of 4 to 5 people building up a pipeline to show and prove it, and then moving teams into it. So it's less hard than you think. Now, how do you get started? Some people choose that the pipeline is the most important thing. Some people decide, I've got a lot of people still using ISPF. Fun. So, and ISPF isn't horrible, it's just not a development tool. You using ISPF is something people are going to do, and they probably should know how to use ISPF, but it's not a modern development tool. It doesn't give you all the capabilities of a modern IDE. So adopting a modern IDE is a good thing that teams can do. It really does depend on where you are as to what the biggest value for you is. And I'll tell you, start with a value stream assessment. Do a value stream assessment of what you're doing across a set of functions so that you really can see what your value stream is and help improve. And maybe testing is the biggest area that you want to address first. Though you end up with this problem of how do I deal with test data and how do I deal with environments, which the pipeline helps with. But you got to see what your biggest business problem is and not think it's so hard to move.
Okay, so this means that we started on a good pace because we are moving out of our SCM, which is librarian, probably until end of March this year. We are working on testing tools, so we are on good pace. The other one, how do you foresee the future of mainframe installations with the rise of cloud providers, cloud services, and let's say multiple projects of migration from mainframe to cloud?
So my definition of cloud includes Z. So let's just start with that sentence. I don't know why cloud and Z don't go together. We have Z in our cloud, IBM Cloud. It has Z hardware sitting in it. We're providing Z Spinup, spin down dev test environments in IBM Cloud. It was announced this week, I think. I know it was announced. I think it was this week. We're starting that process of getting that there. But if we look at Z and the Z that you're running in an environment, it provides a set of value and a set of services that is really, well, not replaceable. You don't go from a high transaction throughput system into cloud effectively, from what I've seen. I actually haven't seen clients successfully move really large, high transaction throughput systems that had guaranteed reliability requirements into the cloud. Now, are they moving front ends into the cloud? Are they moving are they moving pieces? Are there things that don't need to run in Z? Really? Yes. You got to look at what piece should run where. And well, IBM, we're putting Z, starting with Linux on Z and dev test in the cloud. So we're doing that. And if I look at clients who are running Z, they're treating Z like a cloud system. It just happens to be a private cloud, a dedicated cloud. So when we think about this hybrid cloud world, if I can deploy as fast to any system, including my Z, then it's just part of the environment and it's part of the set of things. And we have to be careful about cloud hopefully cloud doesn't mean public cloud, because there are lots of discussions that show public cloud for large companies may not be the most cost-effective answer. It may be that clients have their own environment that they're running a set of things, and then a set of things are in public cloud. So it's going to vary. People are going to run things in various different places. I've been in IBM 34, this summer 35 years. I've seen it all. We went from centralized, Z provided by a few people, we had centralized systems, to this decentralized everywhere, to, well, now we're moving back. Over time, we go through phases, we go through transitions, but I still see Z as that large back-end system. And with what we're doing with AI and needing AI to be close to the data, there's no reason Z isn't going to be part of people's hybrid cloud going forward.
Okay, great. So there is a bright future ahead, and together with the cloud, and these concepts are not overwriting each other. That's great. There is a good synergy between them. And on that note, it's time to end this part. Rosalind, thank you very much for joining us. We are very happy to have you, and hope to see you next time, maybe in person in BEC, as soon as all these problems with travel and all this COVID thing will go a little bit lower. And so thank you very much again, and see you next time. And we are moving to other part of our event.